Welcome, my friends. In this video, we will be discussing sampling techniques. Remember that a population includes all individuals or objects that are being studied. Populations are often large, making it very difficult to collect data from every member of the population. For this reason, we often take a sample, a subset or portion of the population to study, instead of the entire population. The hope is that the sample is representative of the population. There are many different sampling methods, and different methods will be appropriate in different circumstances. The gold standard of sampling is the simple random sample, where every member of the population has an equal chance of being selected at any stage in the sampling process. This also means that every sample of a certain size is equally likely, so all samples of size 20 are equally likely, or all samples of size 100 are equally likely. A simple random sample includes replacement, meaning that once an individual from the population is selected, it is possible for that individual to be chosen again. The simple random sample is a goal that we would like to achieve with any sample. We want every individual in the population to have an equal chance of being sampled at every stage of the process. One way to achieve a simple random sample is to number every member of the population, and then to generate random numbers using a calculator or computer to decide who to sample. Let's take a look at some other sampling methods. First, we have stratified sampling, where we first separate the population into groups, called strata, singular stratum, based on some characteristic. There can be as many or as little strata as needed. Then we take a simple random sample from each stratum. For example, you might separate the students based on major, such as statistics, business, biology, math, etc., and then take random samples from each of the majors in proportion to the size each group is relative to the population. Next, we have cluster sampling, which is very similar to stratified sampling. The population is split into categories called clusters, which are often pre-existing segments of the population. Randomly select clusters and sample all individuals from the selected clusters. Cluster sampling is often used by government agencies and is often applied to clusters representing geographical areas. For example, the population might be elementary school students in Grand Rapids, and the clusters could represent individual elementary schools. Some schools would be randomly selected, and then all students from each school that was selected would be included as part of the sample. Next, we have systematic sampling. To obtain a systematic sample, we must number all members of the population, select a random starting point, and then sample every kth individual, where k is any positive whole number. So if there are 15,000 individuals in our population of students at Grand Rapids Community College, we would somehow need to number every student from 1 to 15,000. Then, let's say we generate a random number from 1 to 15,000, and we get 3. So student 3, Noah, is the starting point. Then we sample every kth student. Let's say that k is equal to 5, meaning that we will sample Charlotte, Henry, and a bunch more people in between, and then you can trust me that we will also sample number 14,998, which is Michael. Sometimes the random starting point will only be within the first k values, so you could generate a number just from 1 to 5 to find your starting point. If the students are numbered randomly, meaning there are no patterns in the data, and they aren't, for example, alphabetized or organized in any other way, then the value for k doesn't really make much difference. If the students are numbered according to some pattern, maybe in the order of when they took their first class, then a large value of k would make more sense. Finally, we have convenience sampling, which involves using data that is readily available or easy to obtain. Convenience sampling is a little bit general, so there are many different types of samples that could be classified as convenience samples. Examples include standing on the street corner and interviewing people walking by, or reviews for products purchased on a website. In either case, there is no method of random selection involved to obtain the sample, which can make samples obtained through convenience sampling biased. Convenience sample reviews can sometimes attract the most satisfied or most angry customers, so aren't really a great representation of all individuals who have purchased some product. Our goal with any sampling method is to choose a random, unbiased sample, meaning that every member of the population has an equal chance of being chosen at any stage of the sampling process. Some sampling methods are biased, meaning that individuals with certain characteristics are more likely to be sampled. But even unbiased samples aren't perfect. Even with an unbiased sampling method, the resulting sample will almost never represent the underlying population exactly. We call this result sampling error, which arises from the simple fact that the sample does not contain all members of the population, so it will never perfectly represent it. Sampling error can be reduced by increasing the sample size. We also have non-sampling error, which results from the use of non-random or poor sampling methods, bias in questionnaires, faulty measuring instruments, or other similar factors. Sampling error can be reduced by increasing the sample size, whereas non-sampling error can be reduced by designing a better sample. Let's take a look at some examples of possible ways to sample 50 finishers from a 5K race. We would like to survey the runners to hear about what they thought about the organization and design of the race, and to ask about any possible improvements that could be made for future races. How would you go about selecting the 50 runners to survey? I have come up with 5 possible sampling methods, and we will decide if each method is a simple random, stratified, systematic, cluster, or convenience sample, and if the method chosen is biased in any way. The first method is to number all of the runners based on their finish time, select a random starting point, and then sample every 10th runner through an email survey until 50 runners have responded. Which sampling method does this sound most similar to? The answer is a systematic sample. Remember that systematic sampling numbers all members of the population, which we have done here. Then it chooses a random starting point, and then samples every kth individual. In this case, k is equal to 10 for every 10th runner. Is this a random sample, or is there any bias involved? Firstly, since the survey is sent out through email, it's partially voluntary, which gives it some aspects of a convenience sample, biasing towards those individuals who are very satisfied or unsatisfied with the race. But assuming that everyone who was emailed actually did respond, the existence of bias would depend on how many runners there are total in the race. Remember that the runners were numbered based on their finish times, so if there are thousands of runners, we may be more biased towards faster or slower runners, depending on the starting point. Perhaps faster runners are more picky about the organization of races, and will bias the survey towards certain answers. We can avoid this bias by increasing the number of k from every 10th runner to, say, every 100th runner. If we get to the end of the list of runners, we can always loop back around to the beginning. A second possible way to sample the runners is to split them up based on age groups, and then to randomly sample a proportional number of runners from each age group. Suppose you decide on who to survey before the race even begins, and track the runners down at the event after they finish to survey them. Which type of sampling method is this? The answer is stratified. This is not a cluster sample because in a cluster sample, only some clusters are selected, and then all individuals from the selected cluster should be sampled. In this case, we are sampling a little bit from every group, which makes this a stratified sample. Is there any bias in the sample? Little if any. As long as the samples from each group are proportional to the number in the population, and the chosen runners are able to be located and surveyed on race day, there shouldn't be much bias. Proportionality means that if 10% of the runners come from the 20 to 24 age group, then 10% of the total sample should also come from this age group. Next, assume that we were to stand outside of the refreshments table after the race and survey the first 50 runners that we can find. Which sampling technique is this? The answer is convenience sampling. In this example, we aren't using any method to attempt to randomly select the runners. We are just letting those interested in answering the survey approach us to participate. Is this sampling method biased in any way? Yes, convenience sampling is almost always biased. Shyer runners may be less likely to want to be surveyed in person. Also, it might be the case that runners upset with a race wouldn't be hanging around after the race at the refreshments table. They might leave as soon as the race is finished. Next, assume that we know which city each runner is from. We separate the runners into groups based on their city, and only include the cities with at least 5 runners. Then we randomly select cities and survey all runners from the selected city through a phone call 1 week after the race. Which sampling method is this? This is a cluster sample. Each city is a cluster, and all runners from each selected cluster are sampled. Is this sample random, or is there any bias or any other problems with the sampling method? In this case, there are a number of different problems. Firstly, we are only considering cities with at least 5 runners, meaning that many individuals from our population can't be selected at all. Secondly, the results are biased towards whichever cities are randomly selected. If the city in which the race took place is not one of the selected cities, then no one's voice from the local community is heard in the survey results. Also, since the survey is to be conducted through telephone, many people will likely not answer if they don't recognize the phone number. Next, assume that we print out a slip of paper for every race finisher. The papers are placed in a box and 50 names are chosen. Each of the 50 names are emailed and told they have won a $10 gift card to which they can claim if they complete a brief survey. Which type of sampling method is this? This is an example of bribery. Just kidding. Sometimes giving out a reward can help you get a more unbiased sample. This is a simple random sample. If all participants' names are in a box, and the box is well shuffled, then each member of the population has an equal chance of being chosen. Technically, we should replace each name back into the box after it's been chosen for it to be a simple random sample, but the difference is small as long as the population size is large. Is the sample random, or is there any bias in the sampling method? It seems this sampling method has tried to get around the problem of lack of email response by offering a $10 gift card to those who respond. This will certainly increase the response rate, and if all participants emailed respond, then the sample will be unbiased. We may want to consider the possibility that offering a gift card incentive will influence the responses to be more favorable. It might be the case that receiving a gift card causes participants to give more favorable responses to the survey, or it might not have much influence at all. This method could be done a bit more efficiently if a computer was used to randomly select the 50 names, instead of printing them out and putting them into the box, but either way works. Alright, my friends, we have finished our discussion of sampling methods. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.